The one thing that I really want us to be looking forward today is that there's a link between all of these different pieces, and that there's a number of different ways that you can do any of these problems. The tools are really all the same way to get to the same answer, because realistically, the real world is going to be like, this is what you're going to be asked to do. You're not going to be asked to put a graph in between. You're not going to be asked to give me a t-chart in between. You're not going to be asked to give me an equation in between. The real world is you're going to get the word problem. You're going to need to answer one of these questions. If you have a boss, he's not going to tell you, hey, I need you to do this by doing this, this, and this. He's going to say, I need you to do this. And when you show up at his office the next day, all he really cares about is, did you get it done? He doesn't care how you got it done, as long as it was legal. He just cares that it's done. All right? And so the reality of it is that we need to figure out to make sure that you understand the links between these things so you can use whatever tools work the best for you. All right? So, starting here, this particular problem starts with a t-chart. We have the x and y. We have the units on the x and y labeled. Now, for this particular problem, the easiest thing to do is to start with the graph, because all you have to do is graph the points that are given to you. So I'm going to start over here on my coordinate grid. I'm going to put some axes on there. I see every value is positive, so I only need this first quadrant. One thing that I asked you to do on the test that many of you did not do and lost points for it on this first problem and on the second problem, and then I stopped taking points away from it just because I got tired of doing it, was for labeling the axes. All right, so the x-axis is dollars. The y-axis is pounds. This is really important because if you ever draw a graph and you don't put labels on the axes, the person who's looking at the graph later is going to have no idea what it is. Or you may have no idea what it is if you come back to it a couple days later. So now I can graph these points, 8, 14, so I'm coming over to 8 and up to 4, 8, 12, 14. The next point is 4, 8, 0, 2. That's a really important point. Why is that a point so important?
It's where it intersects.
Yeah, it's the y-intercept. That's important when it comes to actually writing the equation for our line. And then the last point is 5, 9.5. So 9.5 is going to be between 9 and 10 right here. One thing that a lot of people did not do is they did not use a straight edge. And the straight edge is really important because if we're going to use this graph to answer the questions, which a lot of you tried to do, then we need something to be as accurate as possible. So you should have had out on your desk some sort of straight edge, whether it was a book or it was a piece of paper that you had folded into 4, something that was going to be able to allow you to draw a straight line through these points. All right, so this line represents our situation. The relationship between the number of pounds that we can get and the X dollars that we spend. From here, I can go ahead and answer these questions. And I can use the graph to do it. It says, how many pounds can you get with $2? So it's coming over here and saying, if my X is 2, what will my Y be? And I see that my Y at 2 pounds is 1, 2, 3, 4, 5 pounds. And that comes from this point right here. That's where my X is 2. What is my Y? How much would you pay to get 11 pounds? Well, 11 pounds, that's a Y, so I need to come up here on my Y to 5, 6, 7, 8, 9, 10, 11. And see where my X is when it's 11 pounds. So it looks to me like looking at my graph, at this point, that's $6. Is everybody clear about how you can use a graph to answer these questions? James? Yes?
I understand the question, the answers, but on the test, I put 5 and -3.
I'll look at it again. All right. Now, coming over here, we've got the word problem and the equation left to right. So looking at the equation, we know we need it to be y is equal to x plus something. We do know the y-intercept. In fact, we know the y-intercept a couple of different ways. One, we see it clearly graphed over here. Two, we know it's the y when x is equal to 0. So it's 2. So our slope, that thing we're missing in the middle, is our change in y over our change in x. My change in y here, this is a decrease of 6. My change in x, this is a decrease of 4. Negative 6 over 4. So when I simplify this, negative 6 over negative 4, by dividing by negative 2 over negative 2, that's going to give me 3 over 2. 3 halves x plus 2. To me, the only good way to write the word problem is by labeling the units on the equation. The number of people who wrote equations and never put units on them to A, check that their equation was set up properly, or B, to help them write the word problem, was astounding. We know that the units on the y is supposed to be pounds. The units on the x is supposed to be dollars. And that we're starting with 2 pounds of something. The way that these units are going to line up and cancel out, that's that the dollars is what's on the bottom, and the pounds is what's on the top. Jamari, go ahead and write our word problem. Remember, I said there was kind of like a formulaic way to write your word problem. Your word problem could start with a sentence about your starting point, and that makes sense. So our starting point is we start with 2 pounds. For whatever reason, we have 2 pounds of something without paying for it. So maybe it was, I got 2 pounds free regardless. Maybe it was, I already had the 2 pounds. It doesn't really matter what it is. The first sentence says, I have 2 pounds, and I'm going to say of candy. I have 2 pounds of candy. Sentence number 1 always tells me what is the y-intercept. Sentence number 2 tells me how does it change? What is my rate? Well, if I come back down here to my rate, it tells me that I can buy 3 pounds of candy for $2. All right, well, I can buy 3 pounds of candy for $2. And the last sentence is always going to be also kind of its own little formula. What amount of candy, or how many pounds, this is thinking about what are the units of my y, what amount of candy can I buy if I have X dollars? So that last sentence can always follow that formula. What can I get in terms of y if I have X? What is y if X? That's all that last question always is. What is y if I have X? So, that should cover everything for this problem. Is there anything that anybody... So, on the second problem, we're given the equation. we're also given the units that go with this equation. So the first thing that I'm going to do is I'm actually going to come down to my equation, and I'm going to write it with all of its units. Y equals 10 over 1 times x. Then I'm going to leaf chain switch this so it's plus negative 35. So the units of my y is net worth, dollars of net worth, which means that this y-intercept has to be dollars of net worth. My x is a number of hours, which means for that to cancel out so I can get my dollars plus dollars, this should be dollars per hour. So that gives me a lot of key information that I can use to start writing this problem. I'm actually going to go ahead and write the word problem since I have everything labeled here and I was just thinking about all of the units. So with these units I can go ahead, and again that first sentence is about the starting point. The starting point is negative 35. That means I owe somebody $35. In this particular case I'm going to say I charge $35 on a credit card, which means I owe the credit card company $35. Which is why we have a negative starting point, negative 35. The next sentence, what is my rate? So I have a positive rate of $10 per hour. I am somehow finding a way to increase my net worth in dollars per hour. Generally speaking, when you're talking about dollars per hour, you're talking about the hourly rate that somebody is getting paid for a job. So that's where I'm going to go with this word problem. I have a job. That pays $10 per hour. And the last sentence is always that same formula. What is y if x, whatever. Okay, so what is my net worth? That's y. If x is, or x hours are worked. Mathematically, you could have said, what is net worth if X hours? And obviously in a real world, that wouldn't be a very clear way of asking that question. But mathematically, that would tell me that you at least understood what was going on. That you were looking for a relationship between the net worth Y and X hours. Okay? So now we can move on from here. When I saw a lot of people do this, it looked like the way most people went about doing this was they started with their T-chart. They said, my starting point is 0, negative 35. They said my increase in Y is $10. My increase of X is 1 hour. 1, 2, 3. When I add 10 to negative 35, I get negative 25. So a handful of people went wrong there with their addition. And so we get this, which tells me that when I'm ready to graph it, I definitely need some negative y's. Now, there's some people who stopped their T-chart here, and they assumed that there was only going to be negative y's, but there's definitely going to be some positive y's if we keep this going. We actually get, our next point would be for positive 5. So if we want to make use of this, we probably ought to give ourselves some space to graph some positives and some negatives. So I'm going to put my x-axis right down the middle here. I'm going to label it as x hours. And my y-axis, I'm going to put over here on the edge. And we know it's dollars of net worth. And here, there's two different ways we can go about graphing this. One, so when we're looking at this, we definitely need to graph it. We need to have negative values. I need to have something down to negative 35. I'm not going to be able to count by ones. These all look like multiples of 5, so I'm going to be counting by 5s. So 0 here in the middle. I'm just going to label every fourth one in this particular case just because that's what I have space for, really. Obviously, if you labeled them all, that's probably a lot easier for you to use. But here I'm counting by 5. So my negative 35, my 0, negative 35, we can see that in our t-chart, and we can see that as our y-intercept in our equation over here. And I don't need my t-chart to graph these points. However, the one thing that I will say that kind of was the most frustrating thing to me was when you would have one thing on your t-chart, and then you have a completely different thing on your graph. And you can graph things using your equation without using your t-chart, but you better go back and make sure that it matches your t-chart. It's totally fine. In fact, I probably would not bother with the t-chart on this one. I probably would have just gone, all right, negative 35, so my change in y is an increase of 10. My change in x is an increase of 1. Increase of 10, increase of 1. Increase of 10, increase of 1. And so on, and I probably would have plotted my graph just like that. That wouldn't have been paying any attention to the t-chart. But you know I would go back and be like, all right, I'm supposed to have the point 2, negative 15 on here. 2, negative 15. Good, that point is there. Because if those things don't match up, something is drastically wrong. Draw your straight line, and we're good to go. All right, so looking at this, we now want to come down and answer these questions. It says, what will the net worth be? When will the net worth be 0? So we're looking for when y is going to be equal to 0, because y is our net worth. Well, we can kind of use our t-chart to look at this, and we say, well, it crosses over from negatives into positives between 3 and 4. So we can guess that it's probably somewhere between 3 and 4, something like 3.5. We could come in, we could look at our graph and say, all right, when my y is equal to 0, that happens right here, which we see is somewhere between 3 and 4. Could be 3.5. Or we could go back to our equation and say, well, if I plug in y is 0, 10x plus negative 35, if I solve for that x value, what would I get? Well, add 35 to both sides. 35 is equal to 10x multiplied by 1/10. We know multiplying by 1/10 actually just moves the decimal over, so this is going to be 3.5 is equal to x. All three of those different ways would have given you pretty much the same thing. Now, if you use the graph, it's an estimate. If you use the t-chart, it's an estimate. But all would give you the same idea, that it's approximately 3.5. Jamari, question? Its net worth will be 3.5, or sorry, the net worth will be at 3.5 hours. All right, what will the net worth be in 8 hours? So again, a bunch of different ways you can go about this. And I actually saw a lot of people do this. They went ahead and said, you know what? I'm feeling good about my t-chart. And they just started extending their t-chart. Increase of 10, that would be 15. Increase of 10, that would be 25. Increase of 10, that would be 35. Increase of 10, that would be 45. And so they get down here and they see 8 hours would be $45. Alternatively, we could have come up here and we said, all right, at 8 hours, where would I hit? And again, we see this on our line, tells us the solution for 8 hours would be $45. Or the last option, again, going back to the equation, if x is 8 hours, y is equal to 10 times 8 minus 35. Y is equal to 80 minus 35. Y is equal to 45. Again, a bunch of different ways to go about doing it. You didn't need to do all three. What you needed to show me is that you understood one of the three. Are there any questions about this problem? Things that you need me to go back to so you can finish copying it down? If you didn't have enough time. James.
Can we go back to test number 2, the net hit? Well, please make it back.
For which one?
What was the working you guys?
Yeah, so 8 hours. So we know the hours is representative of our x. There's a couple different ways we can think about it. We can come to our x is equal to 8 on our graph and see where that hits our line. And here it does at 45. We could extend our t-chart like we did here and find out what happens at 8 hours, which is 45. Or we can plug in that 8 hours for x into the actual equation to find out that y is equal to 45. Several different ways you can do it. The equation is always going to be the most exact. All right, let's look at the next one. Interestingly enough, despite the fact that this one might have been, to some extent, the most complicated in terms of like the number values, this was probably the one that you guys did the best on, interestingly enough. I will suggest that there was a gift given to you into this, and that was that if you assumed that the rate was going to be multiplied times x, so that the rate was the coefficient of x, you ended up being okay. What I didn't see on a lot of people's papers were checking that the units actually made this okay. How long will it be for x pounds? So c centimeters is equal to something times x pounds, and our spring is already 4 centimeters long. So that means for our rate, we need it to be centimeters per pound, and that's the way it's given to us, 1.5 for 1 pound. So we end up very easily with y equals 1.5 x plus 4. Not all of you wrote that equation. Some of you said, hey, you know what, Mr. Boots? I know I'm getting ready to graph this. I would greatly prefer for this 1.5 over 1 to be whole numbers. So you multiplied by 2 over 2. So you ended up with y is equal to 3 halves x plus 4. They're the exact same equation. They're just different forms of the number 1.5. It's totally up to you which you choose. And most of you went from here straight to your t-chart, and you said my first point is 0, 4. And then you followed your slope. If you did 1.5 over 1, you added 1.5 to y and 1 to your x. If you did it the way I would have done it, you added 3 to your y and 2 to your x because you used your slope as 3 over 2. And you filled out your t-chart with these 4 points. Everything looks positive here, which suggests to me that I only need that first quadrant on my graph. And I can either graph using my equation or graph using my t-chart. Doesn't really matter. So the t-chart says my first point is 0, 4. My second point is 2, 7. My third point is 4, 10. And 6, 13. For me, I don't like counting out to 13. I don't like counting out to 10. I don't like counting out any of those things. So I probably would have just said, hey, this is my starting point. My change in y is 3. My change in x is 2. Change in y is 3. Change in x is 2. Change in y is 3. Change in x is 2. I would have gotten all of the exact same points. So it doesn't really matter. Draw your straight line. How long will it be if 10 pounds are added? Okay, what is our distance going to be if 10 pounds are added? So one thing that I noticed is that I haven't labeled my units here. I know that my x is supposed to be pounds, which means my x-axis should be labeled as pounds. My y is supposed to be centimeters. So my y I'm going to label as centimeters. That's going to help me answer these questions. And a lot of people, that's why I ask you to put the units on there. It's really more to help you. Because when I looked back at the graph, I was like, I don't know what this is asking me for. But if I know this is asking me for 10 pounds and my stuff is labeled, then I know to come over to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pounds. And come up to see where that hits my line. And it hits my line here, which is at 19 centimeters. Now, I could have plugged in 10 for x. I could have extended my t-chart 8, 10, and gotten that this was plus 3 would be 16, plus 3 would be 19. I'd have gotten the same thing every time. It doesn't really matter which way you do it. If you've got a perfectly straight line that's drawn very well, you're going to get the same answer. Next one says, how many pounds will I have to add if I stretch the centimeter or the spring 10 centimeters? So here, if I'm paying attention to my units, I need 10 centimeters, which means I'm on my y-axis. However, we probably didn't really need to use the graph to do this one because we actually see that point over here when the y is 10 centimeters. We see that in our t-chart that it's 4 pounds. Are there any questions about this problem or places that you need me to go back to so you can look to see the work? On problem number 4, we're given the graph. There's a lot of different places that we can go here. I think the first and obvious place to go is usually to the t-chart. There's usually the easiest link between t-charts and graphs. So when I look at this, I see one point here. This is the most important point. The y-intercept is 0, 8. All right, so we see 0, negative 8 is 1 point. This point is over here is 4, 5. This point over here is 8, 2. And it looks like I've got a point over here at 12, negative 2, but I can actually just continue my pattern down to figure out if that's true or not. This is a minus 3, a minus 3, and a minus 3, so that is going to give me negative 1. And this is a plus 4, a plus 4, and a plus 4. So that gives me 12. Which actually gives me a good start on my equation. For my slope of my equation, my change in y over my change in x is clearly negative 3 over 4. A lot of people didn't recognize the negative here. You should definitely recognize the negative here because the line is clearly sloped downward. So we know our equation is y equals negative 3/4 x plus, and we can see our y-intercept is 8. Here I'm going to go ahead and throw my units onto that. My x I can see over here is labeled as minutes. My y is labeled as degrees. So I'm going to label that over here as well. Y is degrees. X is minutes. Which means that I know that this is going to be degrees. This is going to be degrees per minute, because that's the only way the units cancel out correctly. Since I've already got my units there I probably want to go ahead and write my word problem. Since I'm already thinking about the units. My starting point is 8 degrees. So somehow I have something that is starting at 8 degrees. I'll just make it easy. It is 8 degrees outside. Clearly not somewhere in the Bay Area, but it is 8 degrees outside. First one, always about the starting point. Second one, it's about what is my rate? Well, a negative 3 degrees every 4 minutes. That means I am decreasing the temperature 3 degrees every 4 minutes. The temperature is dropping or decreasing, or whatever verb that you want to use, 3 degrees for every 4 minutes. And that last one, what is y if x? So what is the temperature if x minutes have passed? Don't make it more complicated than you have to. Just follow that formula. Starting point, rate, what is y if x? And all we've got left over here are the questions. When is the temperature 0? So temperature, that's degrees, that's my y. When is my y 0? Well, I can see it on my graph here. Somewhere between, I'm going to have to count this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somewhere between 10 and 11. So if I don't want to actually go through and solve out what it actually is, it's totally fine. You can tell me this is approximately 10.5. Bless you. Has plugged this in because he said that my temperature y is equal to 0, negative 3/4 x plus 8. Add a negative 8 to both sides, you get negative 8 is equal to 3/4 x plus 0, so that cancels out. And then multiply by the reciprocal, 4 over negative 3. And we should get negative 32 over 3 is equal to x, and this is negative 10.6 repeating is equal to x. Okay. And last one, what is the temperature at 9 minutes? So again, I can come over here, my minutes, I want to come up to 9. I want to see where that hits. It looks like it hits my line slightly above 1. So I gave you full credit if you said it was about 1.1. I gave you full credit if you said it was about 1.2. I gave you full credit if you said it was about 1.3, because it's somewhere above, but not quite at 1.5. So approximately 1.2, or if I wanted the exact value, I can plug in 9 minutes for x. Y is equal to negative 3/4 times 9 is equal to 8. All right, that gives me negative 27 over 4, sorry, plus 8, which is negative 6.75 plus 8 is, the exact value is 1.25. So when we look through at this, for the graph, we just need to pick the 2 points. Our change in y is a negative 3. Our change in x is a positive 7. So that gives us change in y over change in x is negative 3 over positive 7, negative 3/7. For comparison purposes, I went ahead and changed all of mine to decimals, so I made this negative 0.42 and so on. For the next one, my change in y, this is an increase of 5 and a decrease of 4 in our x, so my change in y over my change in x is equal to 5 over negative 4. Which is equal to negative 1.25. And I just did that for comparison purposes. You didn't have to change them to decimals, but in order to compare them later, that may be easiest. Coming over here, I need the one for this situation. This is the one that most people missed because they didn't pay attention to the units. I need to know how many more times, so y times is equal to my rate times x dollars plus 20 times. Which that means that I actually need the dollars on the bottom, the $2 for each one time on top. So it tells us that the rate for this one is 1/2, not 2 over 1. Which is equal to a positive 0.5 if I want to compare. And the last one, super easy. We just pull it straight out of the equation, negative 3/2, which if we use our calculator is negative 1.5. So I want to order these from least to greatest. I'm actually going to do that backwards because I see only one number is positive, which means that one has to be the biggest number. So that's answer choice C. And just so I can compare them again, I'm going to put their values underneath it. Now the rest of them are negative. The one that seems to be the most negative is the negative 1.5. So that means that's the least value. That's D. Negative 3 over 2, which is negative 1.5. Then the negative 1.25, which was B. Negative 5/4. And A, which was the negative 3/7, which was negative 0.42. So I got all those decimals, and I just want to double check. That's why I've got them all lined up over here to make sure that I can see that correctly. Negative $1.50, negative $1.25, negative 42 cents, etc. Positive 50 cents, yes, that's the order that I would like to be going in if I was improving here, from least to greatest. Questions about that?